Alright, question number 6. Okay. So in this question, we have the mass of the Earth is 5.97 times 10 to the 24 kilograms, and its orbital radius is an average of, 1.496 times 10 to the 11 meters. So it's giving us the radius and the mass of the Earth. Calculate linear momentum. So we can start off by thinking, what is the equation for linear momentum? So we know the equation is P is equal to mv. So knowing this, we can kind of use these two values to get the answer. Let's go through the junior tutor's solution to look at the process, and then we'll verify the solution. So the total distance traveled by the Earth in one complete rotation is d is 2 pi r. So 2 pi r is just the circumference of the orbital radius. So if we plug this in, we'll end up with the circumference, or d here. I guess they use it here. It's a distance traveled of the Earth. So knowing this, we can calculate this, and then we know velocity. So this variable over here is distance over time. It takes 365 days to complete the full rotation around the Sun. So when it's talking orbital radius, it's talking about, okay, the Earth is going around the Sun, and the full circle takes 365 days. So they use this for the time variable in this equation. You do the calculation and essentially figured out what the velocity is, and then this is just a plug and chug to get the final answer. So let's go through that process. So we have the circumference, which distance traveled is 2 pi r. We're given the radius, so the radius here is 1.496 times 10 to the 11 meters. So plugging this into our calculator, we end up with 1.496 times 10 to the 11, and we get, so 9.4 times 10 to the 11, about. So to get the same answer here, so we're going to use velocity is distance over time. We know for time, we'll write this to this side, it's 365 days. But we want to say this in seconds, so I'll do this down here. So 365 days. So here they just multiply by 86,400. But I'll show you how to get to this number without having to memorize it, so you can just think about this logically. So 365 days kind of is how many days in a year. So to get it to the seconds, we want to think how many seconds are in a day. So we can start off with something simple. We know there's 24 hours per day, so we'll multiply by 24 hours per day. And then we can think about, okay, how many seconds per hour, or we can say how many minutes per hour. So we know there's 60 minutes per hour. And then now we can think about, okay, how many seconds per minute? 60 seconds per minute. So the main reason I did it this way is because I want to get to the point where seconds is the final units for this calculation. And what I was trying to do here is cancel out the other units. So days, I want to cancel out days by having days in the denominator. And then I want to multiply by this conversion factor because it has 1 day in the denominator. Now that I have the units in hours, so use a different color. So we know right away days cancel. Okay, if I multiply these two, I'll end up with hours. I want to cancel out the hours. I cancel them out with something simple. So I know this is a simple conversion factor, and the hours cancel out. And then now I want to cancel out the minutes. I know that I can use this conversion factor, another simple conversion factor, 60 seconds per minute. So this 86,400 comes from 24 times 60 times 60. So if you do 24 times 60 times 60, you'll end up with 86,400. and that's why they multiply with 365 by this number. It's just kind of a combination of all these conversion factors. So that's just how many seconds are in, I guess, per day. 86,400 is how many seconds per day. So knowing this, we can kind of go on to get the time. This is in days. So I'm going to use a different color. So we end up with 365 times 24 times 60 times 60. And we end up with 31. It's a big number. 536,000. Okay. So I'll erase this down here. Okay, so knowing this, I'll make this a little smaller. Okay, so knowing this, we have the time, so this is in seconds. We have the distance, which is what we calculated up here. 9.4 times 10 to the 11, this is in meters. So we kind of just plug this in and do 9.4 times 10 to the 11 divided by this number. So let's do that. 9.4 times 10 to the 11 divided by 31,536,000. We end up with 29,807. This is meters per second. So they end up with 0.29 times 10 to the 5, which is the same thing as this. And now we want to use this equation to get to the answer. So P is equal to the mass. So the given mass is 5.97 times 10 to the 24 kilograms times velocity, which is 29,807 meters per second. And we end up with 5.97 times 10 to 24 times 29,807. So we have 1.78. So I'll erase this up here. So this is equal to 1.78 times 10 to the 29. So looking at this, so here, yep, they have the correct answer, and this is in kilogram meter per second. So kilograms is over here, meters per second is from this, and we end up with kilogram meters per second, and that's the linear momentum of the Earth in this situation. So we verified the solution, and this solution is correct. So correct answer. Great job. And mark this as correct. Let's move on